We'll explore concepts of the future, from ISR drones to tactical loitering missile systems that provide precision strike capabilities. We'll investigate the operational challenges surrounding unmanned aerial vehicles, as well as opportunities derived from advances in autonomy, AI, machine learning that are redefining the future of unmanned aerial vehicles, and of course, the ethical considerations that the US military and other partner militaries are facing in experimenting, designing, and deploying these systems. So today we'll discuss how multi-mission capabilities inherent to unmanned aerial vehicles are expanding their concepts of operation, exploring concepts from the future, ethics. Glad you're here. It's a fascinating discussion about something highly relevant to the future, going to change the way militaries around the world operate. Before we get started, I'd like to go over a few housekeeping items. At the bottom of the platform, you'll find several icons, including a Q&A tab. That allows you to ask a question. We'll be fielding those as they come in. I like people to submit questions early. If you have one, go ahead and stick it in there. The way these typically work is when we reach the end of our hour, we'll probably have too many submitted questions to get to. And often I find that folks are a little bit too shy or hesitant to put their question in there, and then sometimes it doesn't get asked. We've got a lot of participation today. We're very grateful for all of you for joining us. So I want to thank you again. If you experience any technical difficulties, just click the help icon, and a member of our support team will be able to assist you. So joining us today, we have Dr. Okri Franke, Policy Fellow at the European Council on Foreign Relations. We have Scott Wierzbanowski, who's a Program Manager in the Tactical Technology Office at DARPA. We have Colonel Nathan Diller, Director of AFWERX for the US Air Force, and we have Colonel David Barnes, who leads the US Army Artificial Intelligence AI Task Force, and who is a professor of English philosophy at the United States Military Academy at West Point. So thank you all for joining me, and let's dive in. I want to start with you, Scott. First, can you give us a quick intro to who you are and what the Gremlins program is, the program that you're managing at DARPA?
Sure. So I've been a program manager over at DARPA for the last 4 years, with a focus primarily on unmanned air vehicles, autonomy, and the integration of those two capabilities, if you will, in order to be able to enhance the warfighter's capabilities. The Gremlins program is focused on one key enabling aspect of distributed air operations, and that is the air recovery of UAVs to a host aircraft. The thought process here is that if I can do an air launch and an air recovery of unmanned air vehicles closer to the fight, then my overall vehicle could be much smaller, therefore bringing much more mass and quantity, if you will, to the fight. There you are.
Yeah. So this is a fascinating program. It's one of my favorites that DARPA has come up with in several years, and they come up with really cool ones all the time. But if you can imagine it, it's basically deploying a group of aircraft to aid in a mission. They're unmanned aircraft, and then they can be recovered in the air. So an incredibly ambitious idea. And we're going to dive into where we are in that and the technical challenges in terms of creating something like that. But first, let me turn to you, Colonel Nathan Diller. May I call you Nate?
Yes, of course.
Okay. Director of AFWERX for the US Air Force. If you're not familiar with AFWERX, they are an arm to the research and startup community for the Air Force, helping to bring in a lot of great thinking, very new research into the Air Force community, sort of an accelerator. Tell us a little bit about what you're doing at AFWERX right now.
Sure, thanks, and thanks for the opportunity to be here. We've really done a restart on AFWERX just over the last couple of months, bringing in 3 programs under one, and really gets to when we look at this from an Air Force perspective, we look at where we would like to be in the future, the technologies we would like to have. Certainly among them are AI and autonomy. And as we look at the process of actually absorbing those technologies, what we have found that we might need a little bit of a different approach. We might need an approach where not only do we expand the set of technologies, and so fundamental to AFWERX is an improved partnership that we have across industry, certainly traditional, but also the non-traditional startup folks, an improved partnership across the Air Force where we think about concepts and we think about ways of using those technologies. And then an improved partnership internally and with our services on how we bring those technologies across the valley of death, if you will. So how we actually do that. One of the programs that we used to kind of kick this off is Agility Prime. So this is the Air Force's flying car program, and we are certainly intent on looking at autonomy in that there's some fantastic work that's happening in autonomy with those companies. And so finding opportunities to bring that technology in, really asking the question to some degree too, of the ethics of what if we use autonomy, but what are the ethics of not being able to use some of that? So thanks for the opportunity here and look forward to the conversation.
Okay, great. If you're not familiar with Agility Prime, a fascinating program, Dr. Roper, who heads acquisition for Air Force, has described it a few times. Whenever I put flying car in a headline, I immediately get many angry comments. In part because it is a program that extends even beyond the idea of a flying car. It's really a versatile type of an air vehicle that doesn't exist yet on this planet. And to hear Dr. Roper talk about it and to hear other people talk about it, the role that the U.S. military can play in creating a future industry in the United States to propel that into reality. It has a lot of importance, not just for the military, but for a broader discussion about national security and the role that funding research and development at an early stage plays in creating basically industry in the United States that's relevant to the future, and how the military can play a role in that. So a hugely important discussion. So let me turn now, though, to Dr. Oki Franke, who is a policy fellow at the European Council on Foreign Relations. If you don't follow Dr. Franke on Twitter, you definitely should. I get many excellent ideas for stories and a lot of great insight and analysis about UAVs, unmanned systems, everything that's going on in Europe from her. High recommend for a follow. So tell us a little bit about what you're doing now, and give us a quick insight into a European or allied perspective, specifically on autonomy right now. If you can do that in like 30 seconds. Yeah.
Right. Well, thanks a lot for having me. Good afternoon, or rather good evening from London. So I work at the European Council on Foreign Relations, which is a European think tank. So I'm coming at this from a kind of academic background and from a political science, international relations background. And as Patrick already alluded to, my focus really is on European security and defense. And I've been looking into new technologies in warfare, initially drones, now much more autonomy and artificial intelligence, and how Europe in particular is looking at this, what we're trying to develop, and what issues there could be. And of course, there's always this problem that it's really difficult to say, like, what does Europe think on anything? Because, there are some 20 plus countries, depending on what you count, in Europe. But I think what's really important for the US maybe to understand is that within Europe, the thinking on artificial intelligence in the military realm, and maybe specifically autonomy in the military realm, is at rather early stages. And at least in some countries, Germany in particular, there is something of an intuitive reticence or rejection of autonomy in the military realm, because you immediately go into the kind of killer robots debate, which doesn't work, of course. Mm-hmm. There are important differences, though, because France, on the other hand, has shown quite a lot of interest in military AI. It has, as the only European country, a military AI strategy, so much more interested in that. But then again, maybe less interested in working with the US than other European countries. So there's a bit of a range. And I think this is going to be important for the United States in particular, because I felt more interest coming from the other side of the Atlantic more recently, because I think that in the US there's now more interest in working with Europe in order to face China in this area. And so there's a question about transatlantic cooperation that may be worth exploring here today, and then of course also a question about interoperability within NATO and other kind of military cooperations.
Yeah, excellent. I think that's a very good point to bring up, because as I talk to military leaders in the United States, and also NATO military leaders. One of the things that they do like to highlight is that, there's a lot of countries in NATO, but there's only one NATO. And while the military right now, this is something that I hope we'll get to, is engaged in a long-term 10-year effort to create interoperability across the air, land, sea, space, cyberspace, and across the Air Force, the Navy, the Marines, the Army. They are also looking to bring in coalitional partners in that larger networked environment, which they feel is absolutely essential to have overmatch over high-tech adversaries like China and Russia. So how you put all of that together, it's a huge question, one that this military and its partner militaries will be engaged in for 10 years. And the role of autonomy and artificial intelligence, they're linked, but they're distinct, will play a really key role in a lot of the decisions that roll out from that. So let me finally introduce Colonel David Barnes, who leads the U.S. Army Artificial Intelligence AI Task Force. He's a professor of English and philosophy at the United States Military Academy at West Point, and also an ethics point for the U.S. Army in terms of AI and autonomy. So Colonel David Barnes, can I call you David?
Yes, no, absolutely. Please call me Dave.
Right. Can you give us a quick intro to you and what you're working on right now at the U.S. Army Artificial Intelligence Task Force?
Absolutely, absolutely. So welcome, everybody. For those who aren't familiar, the Army's AI Task Force is a new entity since 2018 that resides under the Army's Futures Command, and that restructuring. The idea was to establish a small, agile team to try to engender quick wins for the Army on certain gaps in our research, focusing on artificial intelligence. And I'm in a unique position there as the Chief AI Ethics Officer, providing the Army senior leadership some advice on how to ensure that we not only have these early wins with artificial intelligence, that we set the conditions for the future, for those next 10 days that Patrick mentioned, and moving forward with our multi-domain operations, but we develop an Army-wide culture through education of an AI-ready force, as well as we have throughout the life cycle of all of our AI products in the future to ensure that we're designing, developing them, deploying them, using them within our nation values and the rule of law. And so and I can talk in specifics about one of the project areas later on. Thanks.
Okay. Great, thank you. Yeah, for those of you that are watching at home and you weren't aware that the United States military has a list of AI principles that apply to artificial intelligence, I can tell you that they do. I've seen them, I've talked to the people that have drafted them. I cover AI principles lists a lot, and the one that the US military produced through the Defense Innovation Board is I guess it has to be much rather far-reaching compared to what you see coming out of Silicon Valley or some other places. It runs with the annexes and all of the lists and sort of the manuals of how to implement. It runs like 80 pages. Google's is about 800 words by contrast. So the US military has a lot, many more challenges that it's given itself in terms of deploying AI ethics-wise. And it's going to be a tremendous, challenge to make sure that it can adhere to all those principles and also do everything that it can. But at the same time, I think that the AI principles that the Defense Department's put out are going to be a standard for industry at some point. I really do believe that. So long as they're able to actually live up to what they said that they're going to do. And that's a decision that lots of different folks, different places, different operations, different agencies will be making on a moment by moment, day by day basis. And so that's why we're talking about this now, to see what some of those decisions kind of look like. So with that, let me turn to you, Scott. And can you give us a sense of where we are right now with the Gremlins program and what's going to happen in the near term, the next couple of years, in terms of that program to launch aircraft, have them perform a mission, and then recover them?
Sure. So one thing to really take in consideration is that the Gremlins program, it's an X-plane. It's a vehicle that's there to focus on a couple of core technologies. We're in phase 3 right now of the Gremlins program. and pretty much right in the middle of flight test. Unfortunately, COVID has put a delay in some of our flight test deployments, but we're basically getting everything done that we can in order to, during our next deployment, do an actual air recovery. So we've done a lot of captive flight tests. We've done a lot of flying of the Gremlins air vehicle by itself, doing a ground recovery. But this next time that we fly, which should be sometime this fall, is to actually make everything all work together, where the Gremlins air vehicle will connect with a bullet that is behind a C-130. This bullet is kind of like a refueling probe, if you will, and then once those two connect, the engine shuts down, the wings close up, and then we will bring in the Gremlins air vehicle to the back end of the C-130. Another interesting point about the Gremlins air vehicle is it's rather large. It's about a 1,600-pound UAV that is being used that can have ranges that can exceed up to 1,000 nautical miles.
That's big. Like the term gremlin, you imagine something quite small, but actually we're talking about something 1,600 pounds that's really large. So you're looking right now also at different things that can be put on these aircraft to achieve different mission sets. Give us a sense of some of the payloads that you'll be looking at first, and does that eventually expand to potentially kinetic payloads? And how does that work with command and control?
So when we first started the program, we were really looking at using the Gremlins air vehicle as a sensor. It's a node. That's the biggest thing to consider about this. Is like any other UAV out there, is you could kind of swap out different payloads. You could do different things with it. But what we were really focusing on was using this to put non-kinetic type systems on board. They could be used for geolocation. It could be used for different types of gathering of electronic emissions, or to be used in terms of putting electrical, optical type payloads on there. So really it was more of an enhancer of pushing our sensors forward so that the manned aircraft and the high value assets don't have to get as close to the fight. And because this is an attritable vehicle, we don't really care nearly as much if it gets shot down. Now it's nice that they're getting recovered, because then you can amortize the cost of that vehicle over a longer life cycle as opposed to an expendable system. So we think there's this bend in the curve where you're going to get enough out of this so that it becomes more of a best value asset.
Mm-hmm. So I think it reminds me, I got to say, when DARPA first began experimenting with the Sea Hunter program, which is their big autonomous naval vessel. It's like 100 feet long. They taught it how to basically manage the rules of navigation, so it can watch the rules of the road entirely by itself. And it was originally for submarine hunting. They're going to attach sonar on it so that it can find submarines, diesel-powered submarines from Iran and China, very hard to detect using a lot of conventional radar and sonar. And it wasn't long before the Navy took control of that a lot of folks in the Defense Department, a little bit higher up, started talking about putting missiles on them and the role that they might play in a different type of operation than the one that was just submarine hunting. Would these be, you mentioned EW payloads, so electronic warfare payloads. This would obviously have a huge impact in a war against an adversary that relies a lot on EW for operations like China and Russia. Can you envision, based on what you see right now, understanding that that's not something that anyone has said they want to definitely use this for yet, but can you envision a kinetic payload being a part of these? Is it within the realm of physical possibility? And is it anything that you feel like you might be asked to experiment with or test or prove out going forward?
So specific to this vehicle, no. The reason why is the sensor is up in the front nose of the Gremlins air vehicle. You can have 150 pounds worth of payload, if you will, in this vehicle, and it's more because of the way we designed it. If you were to release weapons from this or make it a kinetic type system, from a technical perspective, you'd rather have all that mass that's going to be released at the center of gravity of the aircraft as opposed to the nose. So that's the biggest reason why it's probably not going to be something that we would feasibly do with this vehicle. It could be explored in other systems, but now you got to decide whether or not you'd want a vehicle such as this 1,500-pound system that goes out and comes back to release weapons, as opposed to just using some of our long-range weapons that we have right now.
Okay. All right. Let me turn to you, Nate. Tell us a little bit right now about what you're seeing in the research community from an AFWERX perspective, and also your favorite AFWERX program in autonomy right now, the one that you think might be the biggest game changer related to autonomy or machine learning.
Sure thing. So we have about 112 different partner companies that are out there in some flavor of artificial intelligence. We have kind of tagged as artificial intelligence in our program right now. We recently had a solicitation for small business technology transfer. So this is the research, the combined research opportunities that we have with the small businesses and with the places that, sorry about that.
That's okay. Tell them hi.
I should have that muted, I apologize.
That's okay.
So some of the opportunities out there for working with the research institutions, as you probably know, the Air Force has a fantastic cooperation with MIT and the work that they're doing up there. They have 10 different projects that they're working, not directly related under AFWERX specifically, but a related AFWERX program there. As we're looking, I think the area where we see that we can make probably the most progress in the near term is more on the autonomy piece of how do we, and this is a good collaboration that we have with both NASA and the FAA, of what does it look like to start to take certain critical parts of the flight operations and remove those so that you're getting to safer operations. That it's not, I think there's fantastic futures in maybe different areas for wartime. Obviously, you're familiar with all the things from ISR perspective. We think really the near-term value is where can we just make current operations safer with autonomy. And so as we look at that, we look at different types of simplified vehicle operations that we're looking under the Agility Prime program, looking at different sensors that do sensor fusion and kind of in this detect and avoid, and being able to see the great work that is happening in the commercial sector. And as you mentioned earlier, make sure, I think the biggest challenge, one of the biggest challenges that I'm sure we'll address more, is kind of the cultural piece. At what point do you actually start to trust, just from the person that's actually in the vehicle? At what point do you start to build that trust among the regulators? What point are you able to start to do that type of certification? And this is where we hope, from a military perspective, we have a good value proposition to the commercial sector where we can do a lot of this collaboration. We just over the last couple of weeks received the authorization for our airworthiness for electric vertical takeoff and landing aircraft that now creates that baseline to establish a new type of propulsion technology. Now, how do we start to continue to build on that that allows, in the near term, we've been doing some great things with our pilot training next program. So to reduce the time it takes to do pilot training, when you take advanced approaches to education and training, you combine those with improvement in autonomy, where the places where you start to gain significant savings in the development of our operators. Eventually, where those cases where you do some of the manned-unmanned teaming that the operators goes out of the system, obviously the value is reduced cost, as well as reduce risk to human life. So that near-term autonomy piece with multiple programs that we're seeing, I think probably has the biggest value. Again, we're a lot of this is prototyping with the idea that we're going to get to fielding with these technologies in the next 3 to 5 years. As you look out on the horizon, all kinds of other fantastic capabilities, but we would really like to get some early wins and really start to show value from a safety perspective, from a cost perspective of autonomy that eventually then starts to build the trust. I've seen some of the other artificial intelligence programs at DARPA of, this key of how do you build trust sooner. I think that to me is the best chance that we have for fast tracking a lot of these technologies and really unlocking the commercial as well as the military potential.
Yeah, I want to get to Dave and talk a little bit about that human-machine teaming aspect, because that's really core to a lot of what the Army is doing. But first, I want to stick with you, Nathan, real quick, and talk a little bit about Agility Prime. If you, in the audience, if you hear Dr. Roper talk about this, he basically makes the point that the future flying car industry, such that it is, could exist either in the United States or it could exist somewhere where the government is more interested in fast-tracking that sort of thing. And it would be a terrible shame if we lost that future industry the way we kind of lost the small consumer drone industry to China with DJI Phantom and that sort of thing. So there's a big effort to make it possible for that future industry to be here in the United States, and the military can play a role in providing the type of test ranges and the type of facilities for basically these things to develop airworthiness, develop the sorts of certifications that are essential before they're going to start carrying people. Can you give us a sense right now of where, I'm not even sure where these platforms are in terms of that testing. I know that a few years ago, trying to cover like drone makers as they tried to push great big military drones into civilian aviation, that question of sense and avoidance, how to see another aircraft and avoid it. There was a lot of question about how you get an unmanned system to do that in a way that the FAA will recognize as reliable, so that, you know, air collision avoidance task, it's something that is, at least a few years ago, was seen as something uniquely kind of human. And we weren't even sure how to describe a autonomous way of doing it. So in terms of creating a platform that's going to meet those very high expectations of safety, whether or not people can trust it to carry humans across the United States. It's different, you know, we're talking about Afghanistan, we've had unmanned cargo since 2011, but in the United States, creating that high expectation of trust, where are we right now in terms of what you're seeing?
Sure. So I think one of the keys, you know, what you see out there among industry, you know, as you said, they've been pursuing this for many years. I think the thing that we found most interesting about industry is, and I think this goes to kind of the larger thesis here, is the value of the algorithm, the value of taking a lot of low-cost sensors and being able to fuse those sensors together. And so from some of the computer vision of being able to do visual detection, merging that with various different types of RF sensors, and being able to find all those sensors at relatively low cost. Again, you know, the cost has to be a huge part of this. We can dream about AI for years, but until you start to get that data, and the only way of getting that data is to get costs, I think, to a point where you're collecting these regularly. As we talk about why we're doing Agility Prime, three kind of main reasons. First, as you mentioned, the strategic industrial base. How do we build that? The second, from this process perspective. So this is our airworthiness. This is partnering with venture capital, for example, different investors that are out there. Part of that process, though, is getting very much to the core of the folks that are doing this testing and getting that data. So I think what you see, there's also this, and then the last piece of that is actually a product. So our early phases, our anticipation is that there are some significant hurdles on being able to certify something that is fully autonomous. That first product that we're looking at is not one that will do sense and avoid fully autonomously. What it will include in many of the companies that are out there, and again, the approach we're taking with Agility Prime, we're not writing requirements. We're basically looking at across the commercial sector and saying, hey, if you can fly before September, December 17th, 2020, we invite you to this air race to certification. And so we have 16 different companies that have applied to that now. We have several of those companies that are through their phase 3, where they've started this airworthiness process. Those companies, what they have done is not said, hey, we're going to go make this fantastic leap to sense and avoid and to full autonomy. Instead, what they're doing is that the hardware's on there, the algorithms are on there, and so they're in a position now to start collecting data. What we hope for a value proposition is that we can quickly start conducting those operations where they're collecting the data, where we're starting to build that trust, where we're sharing that data with the FAA, fantastic relationship with FAA and NASA. We're sharing that data, and now with that degree, eventually now you start in a low risk scenario on DoD ranges to say, okay, if we take this hands off, what does it start to do? So I would say many of the elements are there. The thing that is lacking among both the hardware and the algorithms is that trust piece and the test piece, and so that's where we're inserting. But the level of investment that's gone there, and I think the near term opportunity is not far off at all.
So you already have some venture capitalists that are interested in participating in this sort of thing once it looks like it's more economically viable for them.
So there have been companies said specifically during COVID that the fact that Agility Prime is there and existed was one of the key decision factors for their capital. And it's not just venture capital, but private equity, home offices that are interested, strategic venture that's out there, and the fact that we are creating really this year with contracts that we're writing revenue today for that advanced air mobility market. So far, we've been, there's this variety of hypotheses that we've been testing. That was one that Dr. Roper set out in September of last year. And I would say among those that we've been testing, that one I probably feel most comfortable with saying there are folks who at least have come to us and said that's been a deciding factor.
All right. I might want to follow up on that a little bit in a second, if you can tell me about some of the folks that are getting interested. But first, we have a question for Oki. It seems that the chance of obtaining funds for ethical AI is better than for research of UAVs. What is your observation?
Right. So the ethical AI bit is interesting. So what this question refers to is the fact that the European Union in particular has really wants this idea of ethical AI to be the European brand. And to some extent, it's almost in opposition to the US, or at least it's seen as an alternative to kind of US thinking. And the EU has said that we want to be the place where AI is fully ethical and perfectly done and all of that. What's important, though, is that is on the civilian side. So the EU in particular as an organization has only recently started to get more into the kind of military and defense realm with some funding programs, but overall it is much more focused on the civilian realm. And so the ethical AI discussion in Europe is predominantly, if not exclusively, focused on the civilian realm. So I think that's important. In terms of funds, yes, there are EU programs and EU funds. Some of the people here will have heard about PESCO and EDF, the European Defence Fund, and all that kind of stuff. And this is an effort by the European Union to do more in terms of military and defense research. There was, however, a big discussion about having a clause, and to some extent there is a clause about this money not being allowed to go into, again, killer robots. So lethal autonomous weapon systems are excluded, and so there are some lines that firms aren't supposed to cross. Now, I have to admit, I'm not entirely sure at the moment where the EU funds go specifically and whether France is getting more than anyone else. It would not be surprising, given what I said earlier, that France and French companies seem to be much more interested in this area than many other European countries. Estonia is another country that's interested, so I don't want to generalize too much, but France is definitely leading in terms of thinking. So if they are getting more of kind of specific EU money, that wouldn't be particularly surprising to me. That being said, in the end, what's really going to count is state money and money spent for and by European armed forces and MODs. And of course, here the problem is that there's only so much European defense money to go around, and now with the Corona recession, there's going to be even less. So there are only so many projects that can be funded. Maybe a final note. So one program. There are a number of kind of bigger programs related to military AI in Europe, but one of the programs I find particularly interesting is the Future Combat Air System, FCAS, a Franco-German or Franco-German-Spanish program, which is supposed to, it's a fighter jet system, and it's supposed to fly sometime in 20 years, 2040 or so. Interestingly enough, it's going to be a manned fighter. That's somewhere in the specifics, but they are planning for this manned fighter to also be in a system with a number of unmanned vehicles, and indeed, the famous drone swarms that everyone is talking about. So this is one of those European systems that I think is worth looking at. There are other, especially unmanned combat air systems, from the French Neuron to the BAE Taranis, that are worth keeping an eye on as well. But yes, so I agree with the person who asked the question that the ethical AI bit is definitely an important talking point in Europe. At this point, in terms of the work that's being done on it, it's more focused on the civilian realm rather than specifically on the military.
So I'm glad you brought up Estonia, because I think that provides a great example of all of the different voices and characters that emerge when you talk about NATO. You've got, it's like a big family, and the family doesn't always get along so great, and they have very distinct personalities among them. I was walking down the street in Washington, D.C. 2 years ago, and this little delivery robot drove past me and aggravated my dog. Happened to be Estonian. They're actually leading the world right now in the development of like small delivery robots, and very high up on autonomy. When you look across the European landscape, are there particular countries that are that seem to be more aggressive in funding artificial intelligence or autonomy that has military relevance than others? And are there any surprises there in terms of size? Like, is it sometimes the smaller countries that are moving more quickly into this area than others?
So I think the moment where you qualify militarily relevant AI, the kind of group of countries immediately gets smaller, because I mean, there are only so many European countries that really have kind of military industry to begin with. So I'm afraid I'm going to repeat myself, but I would, in terms of the countries most interested, I would put France. I would indeed put Estonia. I think Finland has been quite vocal on the defense implications and applications of AI recently when it had the EU presidency. So these are three I would emphasize. However, there are also other countries. So Austria, for instance, is an EU country but not a NATO member state, but of course a European country, and that's one of the countries that is pushing much more vocally for a ban on lethal autonomous weapon systems. So you basically have a full range of countries within Europe. And in terms of money being invested, I think the most important there is probably to look at the big ticket items that I mentioned earlier. FCAS, I very briefly mentioned in passing. There's a unmanned combat system, or unmanned combat drone, if you like, in development, called the Neuron, and that is supposedly going to be a highly autonomous system. There's BAE Taranis, so there are a number of it's not even prototype, but it's demonstrator. It's basically in the demonstrator phase, where the bigger European countries and the bigger industry players really want to show what they're able to do.
This brings up a very good point. I want to turn to David. In talking a little bit about the Army's approach to this whole thing, I watched the Army go through the process of standing up Futures Command and put out their new modernization priorities. And there's, new combat vehicles. There's a future vertical lift modernization priority. So they want to make new, basically helicopters, new, basically ground combat vehicles. But helicopter is actually too limited a term for what they want to make. As I got further and further into it, the more I talked to program managers in the Army, what I learned was that they're really looking for, they're not even sure yet. They're going to wait to discover what the best possible solution is, but it's not going to necessarily look like what you imagine a conventional, like tank and tread combat vehicle is going to look like, or what a conventional helicopter or even an unmanned helicopter is going to look like. They've really opened themselves up to a combination of different multi-modular systems, and we're going to see which ones work out best depending on their testing. So can you give us a sense right now of how the Army is thinking about, first, what sort of future unmanned aerial platforms, systems, drones are going to be on the horizon kind of closest? And also, can you tell us a little bit about how the Army right now is envisioning those systems, platforms, drones, teaming with the human and teaming with each other? Because that's a big part of this that other services don't really have, is this constellation of different things on the battlefield that will be both teaming with people, but also with each other in a kind of network. And it still doesn't know yet what exactly they'll wind up looking like.
Yeah, and you raised a great point, Patrick. You know, when you look at not just 10 years out or 20 years out, you know, where we're looking to design a future system from the ground up, right? That'll be fully AI enabled, perhaps you know, at some farther end of the spectrum in terms of autonomy, we'll have legacy systems and hybrid systems on the way, and so we want to make sure that we're maximizing the different efforts, both in academia as well as in industry, to be able to, in a sense, move the bar forward in those directions. One of the main projects that the AI task force involved with is aided threat recognition. And this gets to your point about the teaming. An initial conversation also, both Scott mentioned and Nate followed on with what the Air Force is working on, is what for the ATR perspective for the Army is a team of mobile, air, and ground sensors. And so for us, UAVs are an important element of that, but so are UGVs, right? With a sense of establishing a partnership, a teaming of the human as well as the machine to collaborate on conducting zone reconnaissance. And so a lot of work has been done in this area in terms of twofold. One is in terms of the autonomy of the system itself, but that is, of course, separate from artificial intelligence. And so where the task force is focused on is where can artificial intelligence enhance and allow for a better autonomy and then therefore better teaming. Because again, what really going to matter in terms of employment on the battlefield and elsewhere is the trust that the commanders and operators are going to have in that system. And so we're looking at through ATR, not only train perception, but how to develop increased confidence across different spectrums, optical, thermal, electromagnetic, and even moving forward from the question of whether we should use LiDAR or shifting off of that, because LiDAR is an active sensor. And of course, an active sensor then opens you up for counter measures from an adversary. Mm-hmm. And so all of this is an important aspect moving forward to ensure that the human and the machine are both cooperating, and we develop a trust that goes both ways. And so we use a concept, you know, a soldier-centered design. I mean, we're sort of riffing on what's going on in the industry, but how do we get multiple touch points through the sprints and throughout these different projects so we can ensure that we are taking the considerations of the operator and the commander that are going to actually be employing these systems on the battlefield, as well as the input from the smart folks in academia, as well as the industry piece. And so together we can move forward, because if we don't, we'll find ourselves restricted or going down a certain path. But I think that, you know, this is beginning to show promises, and we're on the glide path to shifting. But part of this push to this is going to be, how do we get AI to the edge? I know this is you know, services are working on different aspects of this, but when we think of these kind of systems, for example, an ATR operating in on the battlefield, it's going to be comms restricted, right? We have to have the ability for the system to both operate effectively, efficiently, and responsibly, as well as the information continuing to be processed to provide that soldier, whoever's up front of that squad leader, with the best information moving forward. And so, you know, the computing power aspect of it is going to be the challenge, the data, the challenge. And I did want to bring up one other point is earlier in the conversation, and when we talk about lethal autonomy and the concerns over that is remember that these algorithms are dual use or multi-use is a better way to look at it, right? They can be repurposed for many things. And so it's very difficult, I think, for any entity to specifically bin the work in artificial intelligence into, say, purely a lethal autonomy kind of problem set, or a decision-making problem set, or, you know, for example, how are we going to do the agile prime sort of concept as well, right?
Yeah.
Because it's similar in terms of our predictive maintenance efforts, and what's different is the data, and in a sense how it's put together in terms of applied to solving a particular problem.
One thing I wanted to get to real quick, and we have one more audience question, but one of the things that the Army is doing right now that I thought is very fascinating is they're teaching unmanned ground vehicles to understand threats and their environments by watching what humans do. So it's sort of the way a kid learns, is by observing human activity, and then you can, based on what they've observed a human do, avoiding different obstacles, dealing with different things, it kind of incorporates that into the way it understands the world. And then it can transmit that knowledge across an entire fleet potentially, or across, which is different from the way humans pass information to one another. What's the challenge there in terms of getting different types of machines to all understand the same knowledge? Is that something that you're seeing, where you actually see this instantaneous transfer from one system to a large group through perhaps an intermediary? Or is that knowledge transfer more complex than I'm making it out to be? Because I imagine it being kind of Age of Ultron, and maybe it's not as simple as that.
Right, and so surely that's what we're going to, right? Because if, you know, a system in real time is responding to its environment, right, and so is taking new information in and data and processing that. Obviously, we would like to spread that across either locally or even globally, depending on the scope. And that is a set of technical challenges on its own. But your other part of the question, Patrick, raises additional concerns. Is how exactly do we model behavior? And it raises a concern about why research in artificial intelligence, in particular in the military use of artificial intelligence, requires not just data scientists and engineers, but it requires a full interdisciplinary participation. You know, what is it about human behavior, and can we somehow model that? And can the AI system model that? Well, I mean, if you think about it, we're not settled on human behavior ourselves, and now we're reliant upon the systems. And so as our assumptions and our trade-offs in terms of how we train the system to then identify and model the human behavior are going to affect how the system models the human behavior. So it's not just the spreading of the information that's a problem, but it's also the sort of the front end, and together it does make it rather complex.
Yeah. All right, we've got time for one more audience question, and I want to turn this to both Ulrike and also Dave, because you are in charge of different areas of the country, or world rather. What is the single barrier to getting UAS into the national airspace? So, excuse me, Nathan, not Dave. Dave may not know, but the big barrier to getting unmanned aerial vehicles into the national airspace, or over Europe, and if there's a distinction among European countries in terms of how willing they are to accept the presence of unmanned vehicles in their airspace.
Sure. Go ahead.
Sorry. Right. All right. So yeah, thanks a lot for this question, because this is actually something I wanted to mention earlier as well, when I think it was Nathan that spoke about sense and avoid, because sense and avoid and the inability to have perfectly working sense and avoid systems led for Germany to lose €500 million on a drone system from the US. We're talking about the Global Hawk, or in Germany would have been the Eurohawk, which in the end could not be certified for the European airspace. And one of the reasons this was a bit bigger than that, but one of the reasons was indeed that basically the aerial authorities here couldn't certify this system because they said it doesn't have a good enough sense and avoid system, or we can't get access to in the technical details of the sense and avoid system. So that kind of shows one of the big issues when it comes to Europe, and that indeed is a very crowded airspace. So the moment you want to use any kind of UAV in the European airspace, yeah, it needs to be able to work with other manned systems, because Europe compared to the US and anywhere else is really small, and there's only so much space to fly aircraft. So I think that That is one of the biggest things to mention. If I may, I wanted to make one very short point on something that Dave said, because the whole debate about killer robots and lethal autonomous weapons, I mean, at this point, as I'm sure you know, Dave, has moved away quite a lot from efforts of banning certain technology or research into certain technology, and has moved more into an area where we say we want to limit certain functions. So I think by now it's rather clear that there are certain things that will be researched, and as you say, it's dual use, multi-use, so you can't, it's really difficult to just say we're not going to build X, we're not going to research X. But the debate in lethal autonomous weapon systems is more about, okay, so we can maybe build an algorithm that can do something, but we want agreements that we're going to limit these functions in military systems. And I mean, this is very difficult, and there's a reason why in Geneva, where they're discussing this predominantly, haven't really come to an agreement on that. But I thought that was worth kind of emphasizing.
Yeah. Nathan, real quick, key barrier to UAS and US airspace.
Sure. I mean, I think it's trust and data. And that's where, if there's not a partnership between DoD seeing some value in this and being able to scale the risk in a way that you start to collect data, you're going to miss that opportunity. Again, what are the ethics of not using this technology? How many lives could have been saved by using this technology? How cleaner could our environment be by doing these things more efficiently? So to me, it's those two things, and that is key to moving this forward and providing greater value for all, independent of commercial and military use.
Okay, great. This has been a great discussion. I think that this discussion on how different different European entities are going to look at that function in terms of ethics versus different research areas, it's one that's going to continue on to the future. All of this is, I've learned a ton. I'd like to turn the program over to Connie Sayers, President of Government Executive Media Group, who's going to be joined by Gorak Hosapian, Vice President, Product Line Management, UAS for AeroVironment. Connie, the floor is yours.
Great. Thank you, Patrick. A great discussion we had. Once again, my name is Constance Sayers. I'm the President of Government Executive Media Group. And I'm excited to continue today's conversation on unmanned vehicles with Gorak Hosapian, who is Vice President of Product Line Management for UAS at AeroVironment. My team 28 years of experience in both military as well as commercial aerospace, places like Cobham, North Carolina. And so, Gorak, it's a pleasure to be with us today. Let's dive in. Can you tell us a little bit about AeroVironment and its mission?
Sure, I certainly can. Hope everybody can hear me. First of all, good morning, good afternoon, good evening, wherever you are in the world. I'm grateful for having the opportunity to join you here. We like to look at AeroVironment as really a technology solution provider that operates at the intersection of robotics, analytics, sensors, and connectivity. Now, whether you're talking about a warfighter searching for the enemy or a telecom provider wanting to talk to and connect people on the digital economy, our mission is to deliver real innovative technologies that help our customers. In other words, we want to do that with unprecedented accuracy and precision. And that's basically the way we classify ourselves at AV.
Talk a little bit about how you've partnered with the Department of Defense in the past. What sorts of missions did you explore? And just for our audience, we are going to share a white paper from AeroVironment in the chat box, which I think will have a lot of really great things. But just talk to us a little bit about your Department of Defense work.
Sure. I'd like to say that we sort of look at ourselves as the inventors of the small UAS business back in the 90s. It was a certain sense of our identification of a need by the U.S. Department of Defense that really got us into this business. So from the early days, what we focused on and what we probably wear with a certain badge of honor is our partnership with the end users within the Department of Defense, not just within the procurement offices of DoD. We tend to get ourselves as close as we possibly can to the end user. We try to understand what does that poor 18-year-old on the front line who has a mission to perform, what does he or she need? And how do we build that capability into our aircraft? And how do we provide that service for the front line, right at the edge of the battlefield? And doing that requires a certain degree of intimacy with the end user. So I think what really sets us apart, not that others don't do that, but what we're particularly proud of, is our partnership in understanding what are the mission requirements, in understanding the logistics of operating our systems in the hands of our end users, and being able to translate that into tangible product features and product capabilities that our end users look forward to use and that they need in their ability to be able to be successful in their operations.
Are there some challenges that you face as a UAV manufacturer, and what did you encounter, and how did you solve them?
Sure. Well, in every business, there are all kinds of challenges, and things have evolved over the time and over the years. We started in this business by providing fundamental ISR solution. That was the need at the time. But UAVs have evolved over the last few years. They've become significantly more versatile and a lot more capable. And when you look at the challenges in facing us today, is really our ability or the industry's ability to continually upgrade capabilities of UAVs with more and more features, more and more performance features, more and more autonomy features in a continuing smaller and smaller package. And when you look at why in the world that's happening, it's fundamentally because the battlefield dynamics have changed and our adversaries have changed and the threats have changed. And when you consider all of those today, we're faced with, industry in general is faced with the need to rapidly innovate and rapidly introduce ever increasing capability in UAVs.
You just mentioned, that the battlefield has changed. So, what do you predict, the future of unmanned systems is going to look like for the military and even beyond that? You even have some commercial experience. It's very interesting to kind of talk a little bit about, future systems.
Sure. Well, so, it's kind of interesting. It's a double-edged sword. As the capabilities of aircraft improve, so does the cognitive load on the individual who has to operate them. And I heard Barnes today very articulately explain all the activities going on in the AI world, at least within the Army. And it's really important to remember that as capabilities grow and improve, it becomes more and more difficult to fly that airplane than less and less difficult to fly that airplane. So we grapple with managing the what you might call cognitive load for the operators. And the reason that's changing is because it used to be in a day when we would fly up and have a ISR payload and be able to collect actionable intelligence data. Today, our adversaries have ways of preventing us from doing that. And they've become much more sophisticated. Technology is much more available. So the requirements in the battlefield have changed. Today, survivability is a really key issue. The ability to operate without a continuous stream of communication so that you don't give away your position is really important. The ability to be autonomous, as autonomous as you can be, is really important. And very close on the horizon are even further improvements in capability where the aircraft or the system, whether it's an airplane or a ground system, can actually engage in higher order decision making. We heard comments about being able to watch and learn like a child in terms of what's happening in the environment. This pattern of life recognition, for instance, is a really, really important issue. I see that distance between the sensor to shooter becoming smaller and smaller and smaller. Unlike maybe others, I don't necessarily see in the next 5 or 10 years a killer robot flying in the sky. I think we are, for a long, long time, are going to keep a human in the loop for a variety of reasons. But I think the trend and the change in the market is towards systems that are ever increasingly more autonomous and ever increasingly capable of making higher order decisions where they can capable of detecting threats and modifying their missions real time instead of a human intervented approach.
Final question for you. You know, are head of the product line. What are you excited the most about? You've got the new Puma product coming out. You've got a lot of really exciting things. Anything you want to tell us about?
Well, yeah, we're going to continue to, we're continuing to invest in our existing product lines, and we're working on some pretty exciting new introductions of new product lines with different technologies, both small and large. So more to come on those over the horizon. But we're dedicated to serving our installed base. You know, it's a privilege to basically own a little north of 85% of the installed base of all the UAVs. And so with that comes tremendous responsibility to maintain it and service our customers. We're dedicated to doing that. And we see ourselves expanding into other domains and getting even better at what we do in autonomy and machine learning, and really expanding our role outside of just our current product lines into other domains.
My guest there, Gorik Hasapian, thank you so much for sharing your insights. And it does look like we're out of time for our program. So I want to thank Patrick and our fabulous speakers, as well as Gorik for participating today. And thank you, our audience, for tuning in. The event today would not be possible without the support of our underwriter, AeroVironment. And the full webcast has been recorded, and you'll receive a link to watch it in your email inbox later this week. So keep an eye out for that, and feel free to pass it along to your colleagues. So we thank you again for joining us, and we'll see you next time.
Thank you.